Yes.
25.
Tyler, 25. Ferris, data entry speed.
Wait, is this for 11?
12.2. So let's start with those two. Okay. 25, was this 3x to the fourth minus 1 quantity squared times 12x?
Yes.
Mm-hmm. Yeah. 3x to the fourth minus 1 quantity squared times 12x with respect to x. Great, which integral is this? 1, 2, 3, or 4? The way it's set up, it's 2. We're actually going to end up using number 1. Why is that? Use your time. U is 3x to the fourth minus 1. What's u prime? And what do we have where u prime needs to live? And what do we want? We always want u prime. So can we make 12x look like 12x cubed? We could if we multiplied and divided by x squared, but what did I caution you guys against? What's the only thing that can travel outside of the integral? Look at the bottom of your tattoo. Russell, 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 Russell. Only constant coefficients can travel outside of the integral. So if I multiply and divide by x squared to get 12x cubed, I can't just drag x squared on the denominator outside. It's going to bounce. It's going to bounce, guys. It's not going to come back. You have to integrate variables that go outside of the integral. And you can't do that with this. So what's the only way to do this one correctly? Whale it out, unfortunately. So what's 3x to the fourth minus 1 times 3x to the fourth minus 1 times 12x? Let's start with this. So we get 9x to the 8th, right? Minus 6x to the fourth plus 1 times 12x. And when we distribute that 12x, we get 108x to the 9th minus 72x to the 5th plus 12x. So now we can integrate that with respect to x. And it's integral number 1. Tricky. If looks could kill, Memo. What's going on?
Huh?
Did you get this one? Can you tell me why you didn't?
Because I didn't even try.
Oh.
I didn't even do it.
Oh.
Yeah.
Who asked for this one? Tyler, talk to me.
I mean, it makes sense, but yeah, that's what, when I thought that it was 12x cubed and was looking
Right.
at like just doing x squared.
And you were trying to like hardwire it to look like u prime?
Exactly.
Yeah.
So.
That's the
this
hard
makes
part.
more sense, I guess, identifying that you need to go through this
Right.
process.
Sometimes the power rule falls through and you have to go back and FOIL it out and do it the hard way.
Okay,
Okay?
thank you.
Yeah, you're welcome, Caitlin.
I'm sorry that whole problem has got me confused.
Okay, talk to me. Where did I lose you?
Well, the head and the one part. So.
Do you have your tattoo out?
Yeah.
Okay. So the process is the steps underneath the integrals. So the first thing is identify the integral you're working with. This looks like integral number 2 because it's some function to a power times another function. So now we say, find u, create u prime. So that's the first step, well, after identifying the integral, right? So u in your tattoo, because we're working with integral number 2, this is what we have.
Yeah, I was just gonna ask you if you could write that at home.
Yeah, so our u in this case is tied to the exponent. So our u is going to be 3x to the fourth minus 1. Okay? And then the step after finding u is creating u prime. So we take the derivative of u. So what's the derivative of this? 12x cubed.
Yeah,
Right. So then the next step is we have blank, we want blank. So we have what we were given. U to the n is set in stone. The only thing we play around with is u prime. Our goal is to make precisely u prime u to the n. Well, we have u and we have n. We have that here and here. So the only thing we get to play around with is u prime.
Right.
Okay, so that's what we have and we want comes from. Groovy?
Yep.
Okay, so then we have to make it look like the template, and there's no way to make this look like that. We need precisely U prime in order to integrate, and we can't make it look like that.
Okay.
So we have to back up, FOIL it all out, and integrate it using integral number 1. So this would end up being 108x to the 10 over 10 minus 72x to the 6 over 6 plus 12x squared over 2 plus k. What was that, Caitlin?
I said, what do you mean integral number 1?
You have 4 integrals in your tattoo.
Oh, okay.
Okay, we were working with integral number 2. It doesn't work, so we have to back up and go back to integral number 1.
And so you haven't finished it yet. It's just, you haven't finished that yet.
Right. So the integral
Integrated, right?
is 108x to the 10 over 10 minus 72x to the 6 over 6 plus 12x squared over 2 plus k. That's the answer.
I guess, where did you get you multiplied the 12 into everything?
Yeah, I just distributed it.
Okay,
So you see how I got from here to here, right?
I just don't get where like the other 3x to the 4th minus 1. Oh, because
It's
there's 2 of
square.
them. Okay. Alright.
Okay, groovy. What else, guys? How do you feel about this one? Nice
Great.
little top knot you've got going on there.
Right?
Yeah,
It's adorable.
sure.
It's better than
kidding.
it.
It's, I would never like make fun of somebody, so it's adorable. Yeah, absolutely.
I appreciate
Okay. Well, let's look at data entry speed then, if you guys are cool with this one. Phew. So much nicer when I actually have a real eraser with me. I don't have to scrub. Look at how nice this is, like butter. So great. Data entry speed. Okay, the rate of change of a data entry speed of an average student is ds by dx equals 5x plus 1 to the negative 1/2. Blah, 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 where x is the number of lessons the student has had and s is in entries per minute. So we have the derivative of the speed with respect to x, and that equals 5 times x plus 1 to the negative 1/2. Okay, where x is lessons. And s is speed, which is entries per minute. Okay. Find the data entry speed as a function of the number of lessons if the average student can complete 10 entries per minute with no lessons. So our nugget, guys, is what? When x is 0, what's s? Yes. So when x equals 0, s equals 10. This is my nugget. That's my little bit of information that'll help me find the constant of integration, okay? So let's integrate this. S is gonna be the integral,
Alright, I hate to ask, but like, how did you know s was 10 again?
because it said it in the problem.
Okay.
Yep, it stated it in the problem. It said find the speed of each student, given that we know that if they don't have any lessons, they can enter 10 entries per minute. Okay? All right. So is this integral 1, 2, 3, or 4?
2,
2, why?
because it's always for this lesson.
For this one it is,
Yeah,
but
yeah.
let's pretend this was an exam problem. Is this 1, 2, 3, or 4, guys?
Oh no.
Because I ain't gonna tell you. I'm not.
How do you?
How do you know? Well, let's start with integral number 1. We only have 2 under our belts right now, so process of elimination. Actually, screw it, let's just use all 4. Can it be number 4? What's the exponent for integral number 4, guys? Is that negative 1? It's not integral number 4. Great, can it be integral number 3?
No.
Is there an e?
No.
There's no e, so it's not integral number 3. Can it be integral number 2?
Yeah.
Why? Because we have a function to a power times something else, right? Is this easily distributable, this 5?
Yeah.
Yeah.
No!
This-
I should have yelled at you, but no! Oh, dear God. You have to do exponents before you do multiplication, guys.
Power rule.
Power rule. Remember how I did the squaring before I distributed the 12x in the last problem? You have to resolve powers before you do exponents. Can I resolve this power easily? No. So this by default has to be integral number 2. Because with me, I can't drag it into only terms of x to the power of n, x to the power of n.
Wait, so if the 5 wasn't there, then it'd be number 1?
Yeah, it would just be 5x to the negative 1/2.
Wait, if it was just x plus 1 to the negative 1/2?
It would still be integral number 2,
Oh, it would.
because you would have a function to a power that you can't resolve, okay? So this is integral number 2, great, because it's integral number 2 looks like this. So what's my u? What's my u prime? What do I have where u prime needs to live?
5.
And what do I want?
1.
So what am I gonna do?
Divided by 5.
If I pull the 5 out, what's left over?
Oh, 1.
1. So I can do that, right?
Yes.
So s equals 5 integral x plus 1 to the negative 1/2 with respect to x. There's a hidden 1 there. That makes my u prime u to the n. What's my integral, guys?
X plus 1.
5 goes along for the ride.
X plus 1.
X plus 1 to the what?
1/2.
Divided by
1/2.
plus some constant associated with speed. How do I resolve this?
Do you plug in them?
Not yet. This is why I want you guys to simplify to a workable point. You can do this one in your head.
Oh, yeah,
Yeah,
You pull-
okay. 2 inverts and multiplies, it looks like 10. This becomes 10 square root of x plus 1 plus k sub s, and this is s over here. We need both sides of this equation, guys. Why? I'm about to give everything values. So I'm gonna plug in what for s and what for x. Yep. What's 0 plus 1? What's the square root of 1? Yeah, what's 10 times 1?
10.
So 10 plus what equals 10?
0.
K sub s equals 0 here. So my real speed function is gonna be what, 5? No, 10. Son of a biscuit, I didn't wanna get my hand dirty. 10 square root of x plus 1, done. Talk to me. Haley's like, yeah. Autumn.
Can you put a step between, or on the right hand side, the top one and the middle one?
This and this?
Yeah.
Okay.
It's going 5 times 2.
Invert. Yeah. So the 1 stays behind, and that's your denominator always. 2 times 5 is 10, and this 1/2 is just a square root. And the reason I make it back to a square root is I don't know what 0 plus 1 to the 1/2 is, but I sure as hell know what the square root of 1 is. Okay? So these things you can actually do in your head, guys. Most of them. Not all of them, but most of them. Ruby? That's affirmative. Yeah. You're not having it today, are you? No. No, Avery, you're good.
No, I am.
You
I understood that, yeah. Makes sense.
okay? All right. How do you guys feel about this problem? What's the hardest part? writing it down in the beginning, getting it into integral form even, right? Just getting from here to here can be a giant pain in the neck, but I taught you guys how to do it. What else is difficult?
I think just having like so many different like things you have to do.
But you have steps for them, right?
Not like this specifically, but like having all the different things you have to do.
There aren't that many though, if you think about it. At the end of each of these application problems, you're gonna need a nugget so you can find your constant of integration. So that's only one additional step. The rest of this stuff is mandated by the steps on your tattoo. Everything we did from the tattoo steps. We made it pretty. We found U, we created U prime, we have blank, we want blank. We made it look like the template, that's step 4, and step 5 is we integrated. And then we just got it into a workable form so that I could easily solve for K. So that's the only additional step on there.
I think the other challenging part about this one for me was the have and the want.
Mhm.
Usually you're going from a smaller number to a larger number,
Mhm.
and then this one.
The opposite.
So then, how do you do that?
Don't overthink it though. You guys want a 1, what are you gonna multiply and divide by? 1. So it wouldn't change anything, right? If I had a 1 divided by 1 here, I would be pulling the 5 over 1 out, wouldn't I? So nothing has changed. That additional little baby step, if you need that to keep your ducks in a row, go for it. But it's not gonna change anything in your final answer. Ruby? Yeah. Awesome.
Show the baby stuff really quickly.
Yeah, absolutely. I will, by throwing stuff at the floor. I want a 1, so I'm gonna multiply by what I want. Okay? I can multiply by 1, but I can make 1 look like anything. I can make it -10 over -10. I can make it 0.5 over 0.5. I can make it 1 over 1. I need a 1, so I'm gonna circle that. What did I not need? 5 over 1. Here's the one that I kept, here's the one that I kicked. It's all there. Oh, you're welcome. What else, guys? Yeah. So we're gonna do more of that today. So if these are still a little shaky for you, guess what? We're adding integrals 3 and 4. Woohoo! They're easy. Don't overthink it.
So just real quick, if it's 5x to the 1/2, then it would be the first one, right?
Yeah, it was just 5x to the -1/2, nothing else. Then it would just be, yeah.
It's only the second one when there's a function,
Let me show you something.
like when there's like a
Yeah, can you do a
Function within,
comparison?
yeah,
function within a function.
yeah. Okay, guys. This is integral number 1. This is integral number 2.
So it's
Tell me
just
why.
parentheses?
It's not about the parentheses. Although sort of, yes.
Because when there's a parentheses, the 5x is tied to the exponent, and then the other one is just the x tied to it.
It's all about the base.
Oh, so power rule.
Your base is a function here. What's your base here?
Just x.
Just x. So
power
yes, it's tied to parentheses, but no, it's not. Like she said, it's about what the exponent is tied to. Groovy? Do you guys see the difference? Talk to me.
So power rule.
Power rule, straight integral. Just like straight derivative and d out dn. Okay? Whole different animal. Does that help you guys? Okay. Awesome. So today, we're gonna complete the integrals. Sort of. My feelings exactly. What was that? Gee, I wonder. You're not bored?
No.
You're
Not yet.
bored, I'll give you something to be
Not
bored
yet.
about. Okay, so far, we've learned x to the n becomes x to the n plus 1 over n plus 1 plus k. And n cannot be negative 1. That's important, guys. And then we learned u prime u to the n with respect to x. And that becomes u to the n plus 1 over n plus 1 plus k. And n can still not be negative 1. But now I'm going to add these two. U prime e to the u with respect to x becomes e to the u plus k. No limits. And then finally, u prime u to the negative 1 with respect to x becomes natural log of u plus k. And in great big red letters, n must be negative 1 in this case. It has to be.
Is this 12.3?
This is 12.3. So this is all on your tattoo. You're just rewriting your integrals.
Is there a name for this?
Yeah, what's your fancy title?
Integrals of logs and exponents. I bet the people right under us love it when I stomp around. Wow, that was mean of me. I'm sorry, guys. Integrals of logs and exponents. So let me just throw you one, you know, because why not? What's the first step, guys?
Make it pretty.
Make it pretty. How do I make it pretty?
Bring it up.
Bring it up by what? I have to drag it by the exponent. Where's the exponent?
Oh, it's your effort.
Nah, it's not the square.
It's the whole thing. By one.
Oh, what?
Before it travels, it must get wrapped
Got it.
for travel. So if it doesn't have exponents, wrap it and give it a power. Then drag it uptown. So what's this gonna get rewritten as?
4x times 2x squared minus 8 to the negative 1.
That's right, which makes this integral number,
2.
I put it,
4.
4. Why 4?
Exactly.
Oh, yeah.
It's the negative 1. That's right. N equals negative 1. This is integral number 4. What's the next step? Don't overthink it, guys. We made it pretty. We told the integral it is number 4. Wait, say that again? So where's u? How do we know which one's u?
I think that is 2x squared.
2x squared. Do you have 5 points yet, Haley? You're about to. Haley made that a square. Great, so Blaine, I'm sorry. Where's u located? Why?
Right?
But literally, u is tied to negative 1, right? So u is located as the base of negative 1. So the base of negative 1 here is 2x squared minus 8, thanks to Haley. And what's u prime? And what do we have where u prime needs to be?
Oh, 4x.
And what do we want? Do we have what we want? So can we just go ahead and integrate?
Yeah.
Great, what is it? Don't overthink it, peeps. We're working with integral number 4, so plug and chug, guys. Natural log of
2x squared minus 8.
done. How many of you wanted to overthink that one?
Why are we doing that log?
You tell me, Adam. Why, what's special about the natural log?
Oh, the e.
There's no e on this.
Yeah.
What's special about the natural log? Look at the tattoo.
Oh,
So what
it
does it
says
give you?
natural log.
Well, yeah, but we don't know that it's natural log. Why do we know that it's natural log?
-1.
The -1 gives it away. Because this is a -1, this is by definition integral number 4. It's the only one where n can be -1, okay? Okay. And then after that, it's just plug and chug. Okay? You guys
So
wanna
if E
Yeah.
doesn't have a limit, does that mean that it can also be -1 or?
what do you mean E doesn't have a limit?
Also, like,
There's no n cannot equal anything on the E. Notice that.
yeah,
Yeah, so it can be anything.
yeah, so
Yeah.
can it be -1?
Yeah.
Okay,
Yeah, because there's no, the reason it can be is there's no thing dividing by negative, or n+1.
yeah,
Or, it's a different format. So our goal is to not make this look like that. Our goal is to make our problem look like one of these 4 things.
Cool.
They're completely separate problems. Okay? Yeah, Cassandra.
Sometimes the power
Mhm.
is like -1 plus x squared. Say that was
The power would be?
the exponent, sorry.
You
So
mean-
where the -1 is, what if it was -1 plus x, it was an actual function?
Okay.
Like we had before, would that still be the full field?
No, because then the power is no longer -1. It has to be only -1, just -1 and nothing else. So what you might see is -1 plus x squared, e to the -x plus 1/3 x cubed. Jeez Louise. So I'm rebuilding your sausage here, sort of. Okay?
Are we now doing like the next one?
Yep. So we've never really had an exponent that looked like that. We've never really had that. We've had exponents that are just numbers, okay? Unless it's an E. Exponentials get exponents that are functions. Look at the location of the functions here. In no way is this ever gonna be a function. In no way is this ever gonna be a function. This is a function. And this is a -1, so in no way is that ever gonna be like a complicated function. Does that make sense? Okay. All right, so now let's take a look at this one. Is it pretty? Which one is it? 1, 2, 3, or 4? Why?
Because of E.
Yeah, the E makes it number 3. Okay, so we just look at it, guys. It's not that terribly difficult. You just look at it to see which one it is. The only one that has E is integral number 3. Great, where's your U? In integral number 3. U is defined as your exponent, right? So what's our U?
plus 1/3 x cubed.
Great, and what's U prime?
Up front, -1.
Never look here, always look here. That's why we create it, we don't just look,
Yeah.
okay? What do you want? This is gonna be fun. Hello? Yeah. Good, how are you? Yes. 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 Kind of in the middle of class. Can I call you when it's out? Okay, thank you so much. You too. Bye-bye. Hang up, hang up, hang up. Do we have what we want?
Yeah.
What's our integral? Well, that was fun. Don't overthink it. Plug and chug.
-x plus 1/3 x cubed plus 2.
Adam, are you leaving?
No, I'm just trying to find my calculator in this clusterfuck that I have in my backpack.
Why are you doing a calculator?
I just, oh, here it is. I thought I left it somewhere. Which was that?
For a mathematician, your calculator's like your comfort binky. Man, feel naked without it,
What's a
let me tell you. That's why I have an emulator on my phone, because I'm like, if I give my calculator away to a student, I need my binky. All right, let's try another one.
Can you do one of those where like,
We're gonna have to do it.
there it would just be like
Yep.
E to the, it'd be like something E to the, U.
Yep, absolutely.
Wait, that one's done already?
Yeah. It sure is. This one's fun. Modifying it slightly just for fun.
Sort of.
Yeah.
I just like once, but the last time I just looked at associated them.
Is it pretty? Can we make it pretty? When we drag the exponent, what travels? So what's our exponent become, guys? Okay. Alright. Now what? So find u, create u prime. This is on the steps. So what's my u?
And 0.5x.
Yeah. U equals negative 0.5x. Does everybody see why? U is located as your exponent here, and it could be the entire thing. It could be a power, for all we know, but it's the entire exponent, whatever is here. What's u prime? And what do we have where u prime needs to be living? Yeah, and what do you want? Always u prime. So what do we need to multiply and divide by, guys? Don't overthink it, be a child. What do you want? So we're gonna multiply and divide by, what kind of 0.5? Negative 0.5, yeah. So here we go. Negative 0.5 divided by negative 0.5 equals what, guys? Positive 1. And when we multiply by positive 1, nothing changes, right? Okay. So what do we keep and what do we kick?
Keep the negative 0.5.
Which one?
Top.
The one on top. And we're gonna kick out this and this. So how do I rewrite this?
250 over negative.
Yeah. Oops. Does it matter where the negative sign goes? Nah. Integral negative 0.5 e to the negative 0.5x with respect to x. So now we can resolve that. What's negative 250 divided by a half? No, it's divided by a half, so it's like being multiplied by 2, right, guys?
500.
So negative 500. Negative 500. Negative 0.5 e to the negative 0.5x with respect to x becomes, we just fill it in, negative 500 goes along to the right, e to the u. Plus k. The hardest part here is convincing yourself that easy is okay. Most of you are going to want to overthink these. I urge you not to. Okay? Questions? Shit. Sorry. Questions so far? My quiet group.
Can you give us a hard, natural log one?
Sure. I can give you a harder natural law one, why not?
Hold on.
Have you guys guys figured out now that we're just doing the same thing over and over and over again? It's just the framework we're working in looks slightly different for every problem, but it's the same thing over and over and over and over again. We just go round and round and round and round and round. That's just mean. I'm not doing that.
Oh, do a mean one. If you can do mean, you can do the not mean.
Okay. So I'm gonna let you guys tough it out and I'm gonna walk around. That's the mean part. Rex is like,
It's always like the algebra that kills you. Like, how do you divide y into y?
you can only translate it into multiplication, something that's been divided and multiplied to begin with. So, for example, what it does equal is this.
So we can do that with this?
Yep, sure can.
Cool.
Again, if it's not prepared for travel, wrap it, give it a little coat of parentheses and a power, and then drag it uptown and change the sign.
How can you have A squared on the top, but there's like A right
And then I think this
there?
one.
A plus B and then you have
What
B
I'm
squared.
saying is you
Yeah.
can't separate things that are added and just make one
You just mean like,
multiplication.
what if there's a y divided?
That's not
I
possible.
know, but you have
I
A
mean,
going
a
into A
divided by a
squared.
plus b is a squared.
Yes.
This is y squared.
I'm trying to
Draw it up
Third
and eliminate the
plus one.
I'm trying to tell you that this is not the right way to do
Oh,
it.
yeah.
This is the right way to do it.
Oh.
Yeah.
Okay,
You
so,
see?
That's what we did.
yeah,
Okay.
So we only
Ferris.
don't do the fourth one.
that is the right way.
Yeah. Cause it's already negative one.
Yep.
So what's u?
Not right.
Y squared plus one.
This is what you want.
Prime.
You have what you were given always, 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 always. Right. So you're just missing the five anything out front.
No, cause this one's just one. Cause you have to,
this is
it's the
how-
derivative.
Yeah, you need to make it a 2y, so you multiply it by.
You look like this, cause like this one, it's like, what's the chance of going for x? And then it's the, that's the derivative. It's not the squared yet.
What's up?
We don't have that. We would have to multiply by two. Yeah. So then it would be,
Times this, you're left over with the two.
What's the derivative of
Y,
y?
so I don't know if I actually there's no one above the Y, which just doesn't make sense to me.
So
But
y squared plus
Oh,
a is
I
equal
wrote down, oh, we know Y squared plus Y.
that's it.
So if I take the, no, when I just take the 1/2 there of 2,
Yes.
get rid of that, take the 2. Then that means you take out 1 over 2.
Yes.
vaya se me olvidó cómo hacer esto.
Here.
So I get to the point where I realize
Yes.
we
Okay, you're
have,
there.
we have this, right?
Yes.
Stay there because the
This
thing
guy?
is 1 to
Keep it up.
This is our U,
That's you.
and this
Yeah.
time is this, that's what we
Now you
want.
just
Yeah.
So,
But you have this, it's y. You have y and you want 2y, not this. This
oh, you're
is,
right, you're right, you're right, you're right. This is just you. No, that's not you.
this is you,
Yeah.
but we want u prime.
What do you want?
2y.
Ya ves como todos empiezan como u prime in the integral.
So then 2 over 2.
Oh, those are cool, they're erasing.
Okay.
Yeah.
Nice.
I'll be right there. Hang on.
Yeah, I think that's true. Please hold.
Okay, well then. Pues nada más tenemos que quitar el 2 and then we have it. We get
Yeah,
rid of
you
that
were
two.
just, no, you were just multiplying by 2 over 2.
Yeah. O como ella lo hace, que nada más pone el 2 aquí. And then she has y.
Because you want this. So you would have a 2 over here. It would be 1 over 2. Look, let me show you. Because you're multiplying by 2 over 2. Because you want 2y. So then when we do it, we would have 1/2 outside to get 2y. And then the but I'm like looking at my notes.
And then you get 2y times y squared plus 1.
Really? So if you multiply it by 2, it's also divided by 2. Did I see a hand back there? Did I see a hand as I was walking to Chandelier? Did I see a
I mean, I
hand?
get it, pero me confundo
Hand,
when I'm trying
hand.
to work it out.
Yes.
I was like, oh,
What's
this
your
is
name?
you?
Carla? Got it. Okay, that's right.
Did I do this right? Or I don't know what I'm doing.
That's right.
Yeah?
No, that's right.
Okay.
Once you have exactly u prime u to the -1, you can integrate.
Okay.
Like trying to explain it like that. Okay, so.
Yeah.
So this should be y squared plus 1 to the -1. Right. So you're losing stuff.
Sí, pues nomás. This is what you have, right? Tenemos el y, this is what we want, the 2. So lo dividimos
So we need a y out front,
and
so
then
we need y
we
up
keep
top.
this 2 and this y, and then we get rid of this one equals 1/2
That's
of
this
this
y. It didn't go away.
Because you get rid of the
The
top
2,
2, so
the
it
only
would
way
be
for
1
it to
over
remain
2.
a 2 is put a 1.
So what did you not start with?
Yeah.
¿Sí le entiendes?
Sí, pero no sé bien cómo explicarle.
It's okay, I'll just watch it.
Okay.
Don't drop things.
Okay, entonces 2
Yeah, the way I kind of remember it is
over 2.
then you have one in there
Estos son los dos que quiero.
There, I think I got it. Where did you lose? You're right here? Okay, so I circled 2y because it was wrong, right? So then it would be, when we take this out, we still want the 2 as the denominator. So there's a 1 on top, yeah.
Okay.
So now it's out and
You're
then
here,
we're
right?
done,
Yeah.
so we just have to integrate
Es que
it.
mira, okay, we want this and we want that. Y este se queda pelón sin nada. Like,
Oh, nothing on top.
pero there's always a 1.
Okay.
That's why it's a 1 over 2, entonces ya lo movemos.
Okay, so wait, the 1/2 is here?
Yeah, on the other side.
And then,
Yeah.
okay, I get all that.
Yeah.
It's because this one related.
Yeah.
So now we do.
What's the rule? Which rule are we gonna use for that?
Not?
Yeah. Wait. Yeah, you're right. U prime.
So we know, so it's a natural log of this height.
Yeah.
So my natural log.
I know
U dx. So we're gonna have an ln. Entonces al final of u,
literally.
You would choose y.
the y squared minus 1, right?
Wouldn't it be that?
That's what you're talking about.
So el final es este.
That's
it?
Right?
Yeah,
That's it?
yeah. That's it. I know. It's like, is it really that easy?
So, like, when it says, like, the natural log, you just technically just go back to your u, the identifier of your u, and then you just put ln, the u, and then plus k. That's
Yeah.
it? I'm over here thinking that we have to do like a whole mix process. Wow.
Yeah.
Yeah.
The formulas like confuse you, but like once you get a hang of it, then yeah.
Porque a mí me confunde que hay un montón de cosas que we're not even gonna write in the end. Like,
Yeah,
we're gonna get rid of this,
yeah,
we're gonna get
it's
rid of
annoying
this.
because like we need to find it, and then like either way we stay with you.
Yeah. It's, why you make me find it if I don't even need it?
Alright, guys.
Whatever your.
It's like, why? Like a soft. Do it. That was my soft. Okay, guys. Is it pretty? How do I make it pretty?
Wrap it around.
Give it a coat and drag it uptown. Great. So it becomes y times y squared plus 1 to the negative 1, right? With respect to y. So that's terrifying. With respect to y. What's my u? Why?
Because it goes with the coefficient. Because the number 4.
Because it has everything to do with the fact that this is integral number 4. And integral number 4 says u is tied to the negative 1. So what's y prime? 2. What do we have?
1y.
What do we want?
2y.
When do we want it? So what do we multiply and divide by? 2 over 2. Okay, so that becomes 2 over 2 times y squared plus 1. I have not changed anything about this function, guys. 1 times anything is still the anything. Nothing has changed. So now I'm going to circle everything I want. I want 2y. What did I not circle? So where does that go? That's right. It goes outside. So now I have exactly u prime u to the negative 1. What's my integral? Natural log of? And what happens to that 1/2 out front?
It gets brought along.
Goes along for the ride, just like we've been doing, right, guys?
Yeah.
So how many of you way overthought this? Is it easier than you remembered? Whack this down. Get this out of the way. Okay. Let's try one on this end of the page. How about this?
So much easier to make videos. Salen mejor en esta clase. Because I don't have that in the computer. He's making the videos, yeah. The whole time he's like texting on his phone. He's like playing with it.
No, and then you're watching the video like,
This is where I want to start crying during the exams. Is it pretty? I said this is when I want to start crying during the exams because I see all kinds of nasty algebra mistakes that make me sad.
Oh, geez.
We need to bring it up and change the sign. What sign? Which 4? This 4?
No. No.
This 4?
No. The exponent.
Yes, this 4. Oh. When I bring up e squared, what goes negative? Is it the 2 or the 1 that's sitting on top of the 2, guys? It's the 2. So what's going to go negative here? The 4. The first 4. X cubed e to the negative 4x to the 4th with respect to x, right? Yep. Yep, I see the pitfalls. I see the pitfalls because I've taught this for a long time, so I know exactly where people go off the rails. The problem is then they don't remember that and they still go off that rail. And I still end up having to drink while I grade your exams, which makes me really sad. No, I'm kidding, I don't really drink, guys. It's not my thing. What's you? Oh, why?
Because that's the thing.
because that's the location of u on integral number 3, which is what we're working with because we have an e, right? So u is your entire exponent. U is negative 4x to the 4th. What's u prime?
Negative 16.
And what do we have where negative 16x cubed should be living? And what do we want? So what do we multiply and divide by?
16.
What kind of 16?
Negative.
Negative 16. Oh. Why must I multiply by the same negative that I divided by? Yeah, if I multiply by negative over a positive, does that change the function? Yeah, because now I multiply by negative 1, so now everything's negative, right? But if I multiply by a negative over a negative, that gives me a positive 1, which fundamentally changes nothing. That's my goal, is to just make 1 look like what I need it to. So what do I need? I need a negative, I need a 16, and I need an x cubed. So I'm gonna circle all that crap. What do I kick out?
1 over negative 16.
That's right, 1 over negative 16. Are you guys okay with a negative 1/16 out front?
No.
Yes.
What?
Talk to me, Caitlin.
Okay, I remember I negative.
You see it?
But the negative is attached to the 1, not to the whole problem,
The
right?
negative is there. Okay, so this, let's just say 4, is equal to this, is equal to this. Okay? I don't care where you stick it, just as long as you've got a single negative to indicate that that term is negative. Groovy?
Okay, yeah.
So it can go up top, it can go out front, it can go on the bottom. I don't care. It's all the same to me. Because mathematically they're the same. What's y integral, guys? How do I check my work? Take the derivative, and where should I end up?
Back to where you started.
Back here, right? Okay, so that's fine. So the derivative of e to the u is u prime e to the u, so this is negative 16x cubed, right? Divided by 16 and multiplied by negative, so that goes positive, so 16 over 16 goes away, and all we're left with is x cubed e to the u. It's the same thing, guys. All we're doing is completing that circle. Yes. Wait, you're Tyler. You're Ty? What is, oh crap, hang on, don't tell me. Frick. You moved and I suck. That's really it, I suck. What is it?
I should just not tell you.
You should just not tell me. A, B, C, hang on, I have to do it in my head.
First letter right, but other than that.
Tristan. Sorry about that, Tristan.
Don't you feel offended though? How could you? How could you
Here.
forget
She
your name?
remembered.
What's my first name? Does everybody know my first name?
Jessica.
Oh my god, okay, does everyone know my last name?
Mrs. Bertram.
Okay, yeah, that's like 4 of you saying it all over and over and over again. You have 1 of me to learn. I have 150 of you. I am trying really hard. Like really hard. Ah. Tyler, Tristan, and Sam in the back, along with Wes. But Russ sits in front of him and likes tie-dye. All right. How about this one? Don't worry, there's gonna be time for you things. Oh, no, let me erase that too. That's a wreck. How do you guys feel about these? Some like these because they're regimented and there's a set of rules for them to follow every single time. Some people hate these because you work so hard on your derivatives that now you're like, this is wrong. It just feels wrong. So how many of you prefer these to the derivatives? How many of you prefer the derivatives? Okay. See that evenly split. That's about right. How many of you abstained? Forcing you to put your hands up. Feeling good about that.
Oh.
You guys ready for fun? These are straight out of the homework, guys.
Which problem?
I don't know, it's an even number. About halfway through.
You don't wanna go for odds?
No, I'm gonna give you those. Here's my hint.
Oh, yeah.
You make two of them. Nice, nice.
Oh, you can?
Also,
So I'm gonna walk around and help you guys for the next few minutes on this one.
Like, you can only do that when there's like a natural law. Yeah, they're also like, which one of these is gonna be on the top of this wall? Maybe that's your turn. Because of this. Oh, yeah, that's
Just remember that these are being added since you moved the minus sign in here, so make sure there's a plus out there. That's okay, you can stick the minus out and look good. Thank you, you're welcome.
Was kind of out of the.
Yep.
Find the prime for this one.
Lo mismo que
Whoa, I'm sorry.
no, it's fine. I was trying to get your attention. See, why do I do this thing?
Abandon the side-to-side notation.
Okay, I thought
You
that
see
was
it?
wrong.
No, it's right.
Yeah, but it
It's right.
confuses me
But
when
the
it's like
side-to-side
that.
notation is hard, so make it top down, so it'll be negative x over 3, or negative 3 times x. Does that help?
Oh, okay. So we have to do that twice basically in this problem.
Yeah.
Oh man.
Yeah.
oh, yeah, it's squiggly.
Is that what she meant?
So like this?
Oh, is that the?
That's it?
Okay, no.
If we bring it up, is it a negative 3? Wait, no, it's negative.
What are you doing?
How do I do it?
You need a tattoo, girl. Let me get you one.
Wait, so
That is not something you can move forward without.
they use x over 3.
But it's negative.
You need it with you every day
Right, that's the u.
Yeah.
for the rest of the semester.
Would it be?
But I was trying to clean it up. I was trying to bring this one up too.
I think you could.
Es que ya me dijo, es lo que me dijo, ¿sí ves? Me va a regañar porque no le hice caso. Sí.
That's better. So you'll be integrating those separately. Yeah, hi Brenda. Hi friend. Hi Brenda. Sorry. In my mind, that's right.
I'm so confused here. Like,
No, my dear friend.
Yeah, for the U prime?
Yeah, just for u, not u prime.
Oh.
Guys,
It's 1/3? Negative
when you
1/3?
bring that exponent up, it's gonna look like that, right?
Right.
Isn't that the same as saying this?
Uh-huh.
Isn't that the same as saying this?
Dang it.
Correct.
Is that an easier derivative? Yeah. Okay, so I like to separate my constant coefficient from my variable so that I can easily take the derivative. We all know what the derivative of 4x is. But looking at that, it's a little harder to tell. That's why I despise the side-by-side notation, and your book persists on doing it.
Yeah,
I don't know why.
So it'll be
So times 1.
negative 130.
I hate that I'm algebra deficient.
Because we have two different units, right? The
I do.
two different, yeah. So for this one, we're trying to figure this one, so we want
Okay.
2x, and we have x. So we would multiply by 2,
One.
and then for this one,
Okay.
so you do
Over 2.
the e, the u, and
Yeah.
then the 1/2 goes to
Yeah.
Yes.
Yeah.
Yes. Yes, you're gonna want to
to the u, yeah. Yeah. For this one, yeah, for both of those.
Yeah, but they're two different terms, so they're gonna use two different techniques. So, what I was talking about here also.
EU. Okay.
Your signs can't just multiply by negative, you must multiply by negative over negative. Sorry, no, it's my bad, I'm sorry. Okay, so we're gonna stick it on the board now. Because I'm seeing the same similar problems.
I don't know about this one, try to make up this one. Because we want negative 1.
Have a 5, yeah. All right, you guys. I'm gonna whip through the solution and talk it out to you guys. And at the same time, would you guys mind passing out the handout? Hopefully there should be enough. There's 72 of the damn thing. So I'll stand if I get going with you. Would you mind, like, starting it? Make sure everybody gets one. Okay, here we go. Jeez, excuse me. Okay, so I'm gonna rewrite this. I'm gonna rewrite this into x e to the x squared minus 5 e to the negative 1/3 x. And I'm integrating all of that with respect to x. Is everyone cool with that? Now I'm going to split them up. X e to the x squared with respect to x minus 5e to the negative 1/3 x with respect to x. Okay, so now I have two u's, two u primes. So my u here is x squared. My u prime is 2x. My u here is negative 1/3 x. My u prime is negative 1/3. So what do I need to multiply and divide by on the first one to get 2x? 2 over 2. So I'm gonna have 2 over 2 times x e to the x squared minus, what do I need to multiply and divide by to get -1/3? This is where you guys are gonna hate my guts. We need a negative sign. We could have dragged this one in, but I'm gonna leave it out there, okay? We need a 3 on the denominator. Guess what, guys? You can use the one that you need on the denominator. So we need this guy. What am I kicking out? That 5 and that -3. So what's -3 times 5? -15 is coming out, times a negative makes it positive 15. Over here, we keep the 2x and we kick out the 1/2. So now we have 1/2 integral 2x e to the x squared with respect to x plus 15 minus 1/3 e to the -1/3 x with respect to x. Again, there's nothing here you don't know how to do, but you have to be diligent. Don't drop signs. Understand what gets multiplied, understand what gets divided, and keep those levels straight. When I said go back to kindergarten, guys, I was warning you. This is the payoff right now. So now what's my integral? Right? What's it? The hardest part here is keeping everything straight and understanding what you're looking at the very beginning.
And there would just be 1K at the end?
1K, because we don't know what K is. K can be anything, right? That's my answer. Talk to me, guys. Most of you got about halfway there. It's cool. Chingshen, did you end up with the right sign at the end? Yes! Awesome. Blaine, Ferris, Caitlin.
Said plus 15.
Should be plus.
Because it was a negative.
Because it was a negative to, well, there was a negative out here, and this was gonna be negative, so it's gonna end up being positive. So you have to keep track of your negative signs. Signs matter here. Ferris.
For the second part, where
This guy?
you find is -3.
Yeah.
When you wanna make it look like what you want, you wanna make it like -1/3 over -1/3.
You could, but then you're divided by a fraction, and that gets hairy too. You saw how much people lose their minds when we divide by fractions. Nobody likes that. So instead of that, I just look at the elements. 1 is already there. I need a negative and I need a 3. So I'm gonna multiply and divide by 3 and keep the part I need.
Okay.
Does that make sense?
So
Awesome.
that's only when there's like a negative fraction, you do that.
You could multiply and divide by -1/3. It'll get you to the right answer. It's just a little bit hairier. Okay? Caitlin,
Our application problems, are they gonna have us like solve for K on something like that?
always. Yeah. Yeah, if we're doing indefinite integrals like this, you always solve for K, so you're still gonna need a nugget.
Work with E.
It doesn't. You have 3 unknowns. You have some thing over here that this function is equal to. You have the x. E is a constant, sweetie. It's a constant, it's not a variable. It's 2.7 something. Just like pi, it goes on forever. And then K is your third unknown. So you need a value for this thing, you need a value for x, and then you can solve for K. Same, same, same. Okay? All right, so here's your assignment, guys. Were there any spares of these, or was the exact amount? Any spares? Really? Who was the last person that had the handful?
I did, that's all of them.
That's all of them? Groovy. Okay, thank you. You're like, there's the spares. They're right there. I'm sorry. Okay. Here we go, guys. Uh, 27. 27 I can do, okay. So 1 through 27, every other odd. I can talk to you about 43. Revenue. Memorization. Compound interest. How many of you guys have had some kind of financial class? Okay, so some of you, this is gonna be new too. I'm just gonna tell you right now, P is constant. P is constant on this. Please don't lose your mind because you've got a P thrown in there. And that's good enough. Okay, all right.